All right, so number one, can you state with any certainty if these two triangles are similar by AA, SSS, or SAS? What do you guys think? You were chatty for the last 7 minutes. What happened? Like all confidence drained out of the room or something. Okay, they're not similar?
No.
Okay, so it's a no. So, there we go. No. They're not because
The angle.
not enough congruent angles for AA and no known sides for SSS or SAS, right? Because in order to use those, you need to actually have side lengths, right? So we can say, nope, doesn't work out. No, nunca. Okay. Now, looking over at problem number 2 on page 480, they want us to see if these two triangles are similar. All I see is sides, so I'm guessing this is a good candidate to try side, 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 similarity on. Okay, so it says first we need to determine if they are similar, and if they are, write the similarity statement like this. Okay, so let's see if they are. Let's compare. So 12 compares to what?
9.
12 compares to 9. Let's write all the ratios out at one time. 8 compares to 6. And the last one, 16 compares to
12.
Okay, so all you need to do is check these. Now, if you just type them into your calculator and get a decimal, you check the decimals, totally legit way to do it. Totally fine. I just prefer we're simplifying because, guys, it gives us practice simplifying fractions, and we need that experience, right? We all, let's admit it. Okay, out loud. There you go. 12 divided by 9, that's the same as 4 over 3. Very good. 8 divided by 6. And 16 divided by 12. This is easy. It's like a broken record. Okay, so we've got proof here. We can now say that triangle, oh, we better name these triangles. What were these names? Let's name these points really quick. I walked away without labeling my points. Shameful. JKL, JKL, and the other one was QMP, QMP. Excellent. So we can say triangle JKL is similar to triangle. Let's make sure you're doing the right order. J matches up with point, see, 12, 16, matched up with 9, 6, 9, 6. So J matches up with M then, okay. So M, K then matches up with P, so MPQ. There we go. So those triangles are similar by side, side, side similarity. And that's it. We're done. So it says determine if they are similar. We did. Write a similarity statement. We did. Explain or justify. We did. So we've done all the things they've asked of us. We're good to go. Do we need to do 2B as well? Do you feel pretty confident about how 2B is going to work out? Which, no? Yes? Okay. For 2B, my question to you is 2B or is it not to be similar? So is it similar or not similar?
Similar.
And if it is, by which similarity statement is it? Okay, so you have to use the vertical angles, right? Excellent. So I'm going to forego doing 2B just because I've ran out of space. I got greedy with my space. Let's move over to number 3. Okay, so number 3, it tells us if triangle, I'm just going to draw a triangle, triangle JKL is similar to what? FGH. FGH. So I've written them out as similar, and guys, to make it easier on myself, I've oriented them the same way. So it makes it easier for us. And it says, what else do we know? That J is congruent to F. Okay. So if that's the case, either we need another angle to use angle-angle similarity, or which sides do we need to match up with? JK matching up with FG, and JL matching up with FH. Very good. So here's the thing. the way they write their proportions and the options they give you, none of them feel exactly right. And the reason being is because they've done what I would call a slide rule. They've slid some stuff around. So they got an equivalent proportion, but it doesn't look the way you were expecting. So let's write it out for ourselves. JK divided by FG, that should be equal to what? Come on. JK compares to FG the same way that, not KL, because if we use KL, then we're not using side angle side, guys. We need JL compared to FH. Okay, so the order here is important. I mean, it would be nice to also get KL and GH, but that wouldn't be side angle side. That'd be ASS, which we know is not something we can use. We only have three possibilities: side, 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 side angle, side, or angle, angle. That's it. So we need these two and these two. So this would be the proportion that I would have set up. Now, if you look at the answer choices they give us, none of them contain those quantities in that particular order. So this one's definitely off because it's using KL, right? KL is not going to work for us. So anything with KL in it, we can automatically eliminate. So F's out, H is out. That only leaves two options, either JK or, either J or G as our only two options. So let's see if I can squeeze the picture and the options in our same. There we go. So here we are. We're looking at our options here. So watch carefully so that you see what happens next. We're okay with this being the proportion we needed, yes? Yeah. The slide rule says that I can take FG. Where can I move him? Up to where? Up where JL is, right? And if I want to, I can move JL down where FG is, right? Yeah. Okay, so I can rewrite this as JK over JL is equal to FG over FH. Are we okay with that movement we just did there? Because now you see one emerge. This looks like one of them. Yeah, this looks like G, although it's been flipped around, right? But that's okay. If you flip this ratio around, they'll be equal. They're still equal. Okay. 1/3 equaling 1/3 is the same as saying 3 over 1 equals 3 over 1, right? So that's okay. You can flip these ratios around. So this matches up with option G. So option G would be the correct option that we need. All right, so tricky question. So just be aware, sometimes the proportions they set up will look different, but they are equivalent to the ones that we were setting up. Okay, so just be aware. All right, excellent. Shall we turn the page? Let's do that. Turn the page. Okay, so we have several things here. 7-4's got 3 theorems. Well, 2 theorems and a corollary. Am I going too quick, folks? Okay. Well, I don't want to rush you, but we do have a good amount to cover today. Today's a pretty good-sized day. We have 3 things to cover. So we're covering 3 sections today. Normally we only cover 2. And actually, before we go to break, I might only do 1 section on one of the days because it's such an important section. I don't want to rush it. Here's the good news. Today's Wednesday, or Thursday. Guess when your homework's due?
Monday, Tuesday.
Tuesday for you guys. So that's nice. So I didn't push it. I didn't say Friday's too soon. That's just rude, right? And I don't want all the emails. Mr. Douglas, there's no way I can do this. I know. Me neither. So let's wait until I'll have you guys do it by Tuesday. What that means, please hear me when I say this, we're having trouble procrastinating. Okay, I'm aware of it. I'm aware that there's an issue there for you guys on your side. I'm trying to find a way with Miss Graham to address that for you holistically as a class, because some of y'all are not getting that work done until much later because you're like, I have other things I got to do first, and I get that. I understand you're trying to manage your time well, but right now there's a misalignment between the assignments you have due and when you're working on them. So in an ideal world, when would you start working on this particular homework assignment? Today, tonight. Right? You would work on it tonight, tomorrow, and by Saturday or Sunday you would basically be done with it. And then Monday, if you need to, you can come and talk to me about it. That'd be in an ideal world. Right now, you're working on assignments today that are due tomorrow. Am I right? Okay, so right now think of it this way, and you need to think of this seriously this way. If you can get this in your heads that it's true and make the shift, life at Victory will be so much easier for you. It took my sophomores last year until the end of the first quarter, and they finally clicked for them. Like, okay, we now know if we work on it tonight, it's fresh in our minds. We can ask questions about it. Like, it makes more sense. We get done faster. Okay. If we wait until the last minute to work on it, things are going to crash on us. Our computers are going to break down. Mom's not going to pay the power bill, or something's going to come up, right? And you're not going to have access to the materials you need. So right now, you need to think in your minds, I'm behind. I'm behind by a day or two in all of my classes. Okay, and you need to let that kind of settle in as I need to freak out a bit, get that freak out of the way, and say, okay, I need to get ahead because right now I'm behind. I need to catch up so that when I get assigned something, I'm working on it the day I get it, or just the next day, but not any later than that. Okay, not any later. If you're working on it the morning it's due, guys, it's going to make your life miserable. From now until you graduate college, it'll make your life miserable. So I'm speaking from a position of experience, having not been given a teacher who ever said, hey, get ahead, because that just wasn't something that was advocated in my high school. Miss Graham, same experiences. So we are trying to speak to you from a lifetime of bad experience. Don't go down that road. It makes your life way too stressful. Okay? That being said, let's knock out these theorems. First one's called the triangle proportionality theorem. Yes, sir. Yeah, of course.
Did it record your...
Yep, it records what I'm saying and records a little bit of what it can hear you guys just a little bit. But if you notice, every time I have you respond, I restate it. That way it can pick up in case it didn't catch it. Okay, and I edit it too. Sometimes I'm like, that video is no good. Oh, that audio is terrible. Or if it was a particularly good joke, you know. So, okay.
So every joke that I crank back to you, they can hear.
Sometimes. All right, so shall we proceed? All right, here is the triangle proportionality theorem. You guys ready?
Yes, sir.
Okay, it says if you have parallel lines, you get proportional parts. What does that mean? Well, in this particular problem, that would mean if BE is parallel to CD, then AB over BC is equal to AE over ED. Now this is incredibly useful. This means if you ever have a scenario like this, you can now set up a proportion to solve for missing parts. And you don't have to set it up comparing the legs of the triangles. You can just use the segments. I'm comparing AB to BC. That's just these two segments. These two segments are now proportional to these two segments. So that's really handy. That also means you can now determine if two lines are parallel if you have the numbers for these sides. If you find that they are proportional, it forces these lines to be parallel to each other. So you get similar triangles, you get congruent angles, you get all these extra properties that come back to you. So that's why it's an if and only if statement. Proportional parts mean the sides are parallel, and if the sides are parallel, then you get these proportional parts. Okay, so this is a nice piece. This is a very important theorem. I would star this theorem if I were you, as in come back to this often and review it because it gets used a lot. I see it on tests, I see it in quizzes, I see it on a lot of the other concepts that you get taught. Okay, so big one. Okay, next one down. You ready? Triangle mid-segment theorem. You're like, mid-segment, so the segment's in the middle? Yep. More to the point, it says this. If J and K are midpoints, that means JK is a mid-segment and JK is equal to half of FG. And the JK is parallel to FG. So
Wait, can you repeat that?
Sure.
Right there?
this says if if J and K are the midpoints of these two sides, right? That J and K are where the midpoints occur. They bisect basically the two sides. That means this line segment here, JK, it's actually half the length of FG. So JK is half the length of FG. And JK is now parallel to FG. They're running in parallel to each other.
So what's that in the box? What's about the wording?
JK are midpoints. Okay. If J and K are midpoints. And to me, this particular theorem isn't like hard to make sense. I'm like, oh, okay, yeah. Obviously, if you look at the component pieces, you go, oh, this triangle, can you see that it's 1/2 the length of that side? This side is 1/2 the length of that side? 1:2 ratio. So therefore, everything else should be the same ratio of 1:2, right? So that means this should be 1 compared to 2. Okay, pretty straightforward. Yes, ma'am.
Question, you know where the arrows are?
Yes.
What's IFF?
If and only if.
Oh.
Okay, this means it's a biconditional statement. It means you can start with this information and it leads to this information. Or if they give you this information, it leads to this information. They work both directions. So the statement and its converse are both true. Excellent question. Oh, just stretching. Okay. That's okay. All right, let's work out one more theorem, and then we're going to quickly work some problems, and we'll pretty much be done for the day, I think, because we'll be running pretty short of time. All right, last one. Here we go. All right, so proportional parts of parallel lines. This is actually directly from the triangle proportionality theorem. It comes right from it. So let's just quickly make sense of this one. If the lines are parallel, the parts are proportional. So far, so good? Right? So coming down here, if these lines are parallel, guess what happens to these parts? It really is the same theorem, isn't it? But instead of a triangle, it's just parallel lines with lines that eventually will make a triangle, right? So it's going to be the same statement. Okay, so I'm going to say if AE is parallel to BF, and that's parallel to CG. So basically, if all those lines are parallel, I don't know why I put a line at the beginning. That was silly of me. So if AE parallel to BF, parallel to CG. So those are all parallel, then we get proportional parts. So we get AB over BC is equal to EF over FG. Very good. So the name of the game, guys, making proportions, making these equations and solving them. So now we can prove if a set of lines are parallel, or if we know the lines are parallel, we can find out what a missing segment length is. All right, I think you and I are ready to fly through examples 1, 2, and 3. They will go really quickly. Okay, you ready? Are you ready?
Yay!
Okay, just want to make sure before I move off. Here we go. Such enthusiasm, like it's almost a time to leave, but guess we're enthusiastic. We're ready. So if you look at the, here we go. First one, okay, there we go. So if you notice, we have parallel lines. Therefore, what can we say about these segments? They are proportional, so let's set up our proportion, which will be 12.5 divided by equals 15 divided by TQ, because we don't know what it is. Okay? Really easy, guys, right? Just setting up a proportion. Yep, that's it.
15 over
TQ, because we don't know what TQ is, right? So we can just call it TQ, or we can call it X if you wanted to. Right? Dummy variables. All right, so cross, multiply, and divide. You go ahead and work that out. I'll give you 25 seconds. Go. 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, very good, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So, it's right there. It's okay, Francisco. It's okay. It's okay. Hey, you're trying. That's the important thing. So, okay. Points for trying. Points for trying. All right. So if you didn't do it my method, as you see, I didn't use a calculator here. So if you use a calculator, I forgive you for that.
Sorry.
Okay. Yes. Thank you for the apology. I just said that, hey, I can actually do this by hand. So I did it by hand because it's possible to do by hand. All right, all I did was I used the slide rule, guys. I moved TQ up to the left, right? So that's where TQ is. He's by himself. I moved the 5 up to the 15 and the 12.5 down to where TQ was. I just moved all these pieces around, and I got this expression, right, this ratio. And I said, hey, 12.5, that's not fun to play with. Let's multiply it by 2 on top and bottom. That'll make this into 25. 25 is the same as 5 times 5. We're okay with that? And then I broke 15 down. I factored it, basically. 15 is 3 times 5. So 3 times 5. Go ahead, another 5 there. There's another 5, and then the 2 from multiplying right here. So here are all of the factors. I then divided out the things that were common to both, and you left with 2 times 3. All right, moving on. You ready? ¿Son listos? Oh, we're not ready at all. We're moving on without me. Okay, that's fine. Here we go. Number 2. It's got 3 parts. The first 2, pretty easy. The third one's devious. You ready? Here we go. DE. We're trying to find segment DE. What do we know about segment DE? There's a name for the segment. We've learned now. It's to the left. It's a mid-segment because D is the midpoint of this side and E is the midpoint of this side. So this is a mid-segment, which means it's half the length of this side. So how long is it? Very good. Excellent. All right. DB has the same property. If you noticed, DB, is part of AB. And the only thing we can compare to AB would be FE. See that? Now F is the midpoint of this side, right? Marked as so. E has already been noticed as the midpoint of this side. So this is a mid-segment. So this is 9.2. The whole thing would be how much? 18.4. But we only need half of that, so 9.2 as well. Oh, okay. So these are actually congruent pieces. That's kind of cool. So this is going to be 9.2. All right, doing so far so well. I want to move a little bit faster. So the measure of angle FED, this one threw me for a loop the first time I looked down. I'm like, wow, how do I find that angle? This is an angle they want you to find, by the way. FED, I'm going to mark it for you so you can see it a bit better. It's this angle right here. Now, gang, there's something we haven't used yet in this picture. If this is the mid-segment, what does that tell us? If it's a mid-segment, what do we know? Well, this part we already knew, but the other piece is that you have parallel lines, right? Parallel lines means you have angles that are congruent to each other, like alternate interior angles, corresponding angles, and so forth. Okay, so look at angle FED. The only angle they give us is this angle right here. How are those angles related? They are alternate interior, because FE is parallel to AB. So that makes this line an alternate interior angle. It's hard to make sense of, but those are actually alternate interior angles. So FED is actually 82 degrees. Very good. Okay, I had to think about that for a few minutes. I tried finding all the other angles first. Like, I was going crazy trying to figure out that angle. I was like, oh, I'm working way too hard at this. And now that I see it, I'm like, I'll share this with them. Okay, you got one more I want to do with you, please. Okay, example 3. Guys, what do you think we're going to do with these expressions? Lines are parallel, therefore proportional. So we can say that 8 over 8 is the same as 7x minus 2 over
4x plus 3.
Excellent. So 8 over 8 equals 7x minus 2 over 4x plus 3. Now, obviously, from here, you're just cross-multiplying, right? But I would like to save you some time in doing the cross-multiplication. There's a shortcut for this particular one. Can you see 8 over 8? What's that really simplified to? Sir? Well, that's 7x. So sorry. Yeah, so this is really just 1 over 1, right? Equals 7x minus 2 over 4x plus 3. Yes. Yep. Okay, I know it's time to go. I'm going to cross multiply so you guys can at least see the rest of it. So cross multiplying here, you get 7x minus 2 equals 4x plus 3. And now you can solve. All right, gang, that's all we have time for today. Listen carefully so you're aware. Tomorrow we're doing a relay. Yes, fantastic, a geometry relay. I'll tell you guys about it tomorrow. We don't have time. It's fun. It's a competition for extra credit. Second thing, you have homework. Start working on it when? Today. Okay, as well, the last section, I want you to take notes over. I'll see you tomorrow. Have a great day, guys. See you later.